Hello students, in this video we are going to discuss about galvanic cell, which is also called as Daniel cell. Cells are quite familiar to in our daily life. We'll come across the different types of cells that is defined as the cell is a device which convert chemical energy into electrical energy. That means a device in which chemical energy is converted into electrical energy is called as cell. As we are come across the different type of cell in our day-to-day life, like the cells used in clock, watch, remote and inverters. So let us discuss the basic principle of construction and working of a cell. So here we are going to discuss a simple cell, that is a galvanic cell, which is also called as Daniel cell or voltaic cell. This is a construction of a cell, that is a galvanic cell. Zinc copper combination is here. So let us discuss the construction part of the cell. For this, two containers are taken, that is different containers are taken, in which a zinc rod is dipped in zinc sulfate solution and a copper rod is dipped in copper sulfate solution. So in the two different container, in one container zinc rod is dipped in zinc sulfate solution and the copper rod is dipped in copper sulfate solution, and both are taken in the different containers. Here zinc rod and the copper rod, these are called as electrodes. That means here this is the zinc rod and this one is the copper rod. These are called as electrodes. This is called as electrodes. Here these electrodes are connected to each through a metallic wire, that you can see here, a metallic wire which is connecting the two electrodes. So here one of the electrode is negatively charged, the other one is positively charged. Here the zinc rod is dipped in zinc sulfate solution and the copper rod is dipped in the copper sulfate solution. Here these solutions are termed as electrolytes. So this is important terms we are using here. Electrolytes, that means electrodes are dipped in electrolytes. So here ZnSO4 and CuSO4 are electrolytes and zinc and copper rods are the electrodes. Here these two are internally connected through a U tube, or we can say an inverted tube, that is called as salt bridge. That you can see here, the salt bridge is a inverted tube that is touching the two solution. So here the zinc and copper, that is externally connected through a metallic wire, and the two containers are internally connected by a salt bridge. Here in the salt bridge, the concentrated aqueous solution of KCl or KNO3 or ammonium nitrate, that is NH4NO3. The concentrated solution of these are taken in the salt bridge, that is in the paste form. So that is the construction here, and here a voltmeter is used in order to identify any deflection. That any deflection takes place in the voltmeter shows the formation of current, or the current is formed or not, that we can identify it with this voltmeter. So let us discuss the working of the cell, that is a galvanic cell. The construction we have already discussed, that is the two electrodes, copper and the zinc, are dipped in the electrolytes, that is zinc sulfate and copper sulfate, which is externally connected through a metallic wire, which is connected between, a voltmeter is connected between them, and it is internally connected through a salt bridge which consists of concentrated solution of aqueous, that is a concentrated solution of KCl, that is called a salt bridge here. Now let us discuss its working of this. Here, in this, the reaction is taking place, that is oxidation and reduction both is taking place simultaneously. That means here the reaction is a redox reaction. So the oxidation here is taking place, that is at anode. This electrode is here, the actus, it is called as anode, and the copper electrode is called as cathode. So here the reaction is taking place at anode, that is zinc is giving rise to 2 electron, so it forms the zinc ion, that is Zn2 positive. So here the zinc rod, this having the zinc, so here it loses the 2 electron, and that 2 electron, it through the wire it flows and it reaches to the other container, and the zinc ion which is formed here, that is flow into the solution. So here the flow of electron takes place, therefore there will be a deflection in the voltmeter, because flow of current, that means flow of charges is, we can call it as a current. So in this way, when it loses the 2 electron which is flow through the metallic wire and reaches to the other container, we can say that there is a flow of charges, that is a flow of electron is taking place. So we can say that there is a current formation here, that is chemical energy is converted into electrical energy. And what happens in the next container, that is here the copper sulfate, that is in the solution which have copper ion, Cu2 plus ion, that it moves to the copper rod, and because the 2 electron which is given out from this next zinc is taken by the copper ion, that is copper ion will gain the 2 electron and form copper. So that means in the second container there is a formation of copper, that is actually start to depositing on this electrode. So here what happens when this process continues, here the zinc electrode, that is lose the weight, and here because there is a deposition of copper, because there is a formation of copper here, so because of the deposition of copper on this electrode, it weight increases. So here what happens, the zinc rod loses the weight, but the copper rod gains the weight. So here as the process will move, here what happens, we can find out that the zinc rod is simultaneously loses the weight, and here what happening, here the copper rod gains the weight because of the deposition of copper here, and because here the zinc is converted into zinc ion, therefore it loses the weight. So here what is the role of salt bridge here, that we need to discuss here, because here there is a conversion of chemical energy into electrical energy, that is due to the flow of charges as here takes place, because in anode oxidation is taking place due to the loss of electron, and in the cathode region reduction is taking place, that is due to the gain of electron. So here what is actually taking place, redox reaction is taking place. Here what is the role of a salt bridge that we need to discuss here, as here the salt bridge is defined as it is a bent tube consists of electrolyte KNO3, KCl, etc. So first of all let us discuss its function. As here when the process continues, what happens here, there is a zinc ion, concentration of zinc ion increases in the electrolytic solution, that is in the anode region, and what happened here, the copper ion, the concentration of copper ion here decreases. So here what is happening here? In this region, that is in the anode region, the concentration of Zn2 plus increases because here the formation of zinc ion is taking place, and in this the concentration of copper ion decreases because here the copper ion is converted into copper. So here when the zinc ion concentration increases, it start to depositing on the electrode. So here because electrode is negatively charged, the zinc ion, its concentration increases in this process. So there is a deposition of zinc ion on the zinc rod. So because of this what happen, the flow of electron will be is not easily takes place because the electron will not be given out easily. But in the case of the second container here, the concentration of copper ion decreases. That means what happen here? The electrical neutrality get disturbed. So in order to maintain the electrical neutrality, in order to continue the flow of electron, here the salt bridge is used, and this salt bridge having KCl. So as the concentration of zinc ion is increased here, so what happened? KCl in this the negatively charged ion, that is Cl negative, will flow into this container. So in order to neutralize the excess of zinc ion, that is the excess of positive ion is neutralized by the negatively charged ion present in the salt bridge. And similarly here the concentration of copper ion is decreased. As the concentration of copper ion decreased, so what happened here? In order to neutralize or in order to maintain the electric neutrality, here what happened? The K plus will start to migrate into this container. So because of this reason, the electrical neutrality of these will be maintained. So the two important first function is it maintains the electrical neutrality of the cell, and the second one is, as we know that the circuit should be complete. As we can see that here only the circuit is complete because there is no direct connection between these two rods. So how this we can make the circuit complete? Through this salt bridge. So here the function of a salt bridge is, first function, it permit the passage of electric current internally. That means it completes the circuit internally. It maintains the electrical neutrality of the solution. So these 2 points are the quite important point or the function for the salt bridge. That is, it completes the circuit internally and it maintains the electrical neutrality. And the other 2 important points are, it prevents the intermixing of the solution and it does not take part in the cell reaction. So here the K plus and Cl negative which is there in the salt bridge does not involve in any of the cell reaction taking place in the cell. So these are the very most important question, what is salt bridge and what are the functions of salt bridge. How to write a cell representation for any cell, that we are going to discuss here. For this galvanic cell, that is zinc copper galvanic cell, the 2 reactions which is taking place at anode, that is oxidation, and at cathode, that is reduction, which is given here. So on the basis of this equation, how we write the cell representation here, that is we are writing the cell representation for this cell in this way. That is here the reactant, look at here in the oxidation state, the reactant is zinc. So first we are writing the reactant Zn, and that is actually in a solid form, therefore in bracket it is written S. And what is the product here? That is zinc ion is the product. So the next we have to write the product zinc ion, that is in the aqueous state here, and there is a separation between the reactant and product by a slash here. So that is a Zn slash Zn2 plus. Here this portion, that is the left hand side of is represented the anode, and the right hand side we are representing the cathode side. So whenever you are writing a cell representation, the anode side that is written on the left hand side and cathode reactions are written on the right hand side, and in between these there will be two lines here that you can see here. These are representing the salt bridge. So while writing the cell representation, first you make the two lines, as you can see here, two lines that is representing the salt bridge, and the oxidation reaction, that is the reaction taking place at anode, should be written on the left hand side of it, and on the right hand side of it the reduction reaction is written, that is reactant bar product. Here zinc is the reactant bar zinc ion is the product. On the next side here, that is copper ion is the reactant and copper is the product. So copper ion bar copper. So this is what the cell representation. Here in this reaction, because the anode reaction that you can see here, zinc is giving rise to Zn2 plus, and the cathode reaction, that is silver ion, is giving rise to silver. So how we write the cell representation? In this way, that is here it is given. First we are writing the anode reaction on the left hand side, cathode reaction on the right hand side, and in between them we have to keep the two lines. Here the reactant is zinc, so we are writing the symbol for zinc in bracket solid. Then we have to give a slash in between this. Then we have to write the zinc ion, that is Zn2 plus, which is the product here. Next here, which one is the reactant here? Silver ion is the reactant. So reactant, then bar, and the product is silver. As here in the balancing, whenever there is a stoichiometric coefficient like twice here, it is no need to mention in the cell representation. You can see here in the cell representation the twice is not mentioned. So these are the way to write the cell representation. So in the galvanic cell that we have discussed here, that is this zinc copper galvanic cell, the cell representation is Zn bar, ZnSO4, 2 bar, copper sulfate, bar Cu. Here instead of zinc sulfate we can write zinc ion, and instead of copper sulfate we can write copper ion, that is Cu2 plus. So while making the cell also, we usually represent the anode side, that is negatively charged side, that we are usually made on the left hand side, and the cathode side, that is we are usually made on the right hand side. So here left hand side is the anode reaction and right hand side is the cathode reaction. So here there is a flow of current from anode to cathode. The flow of electron is taking place from anode to cathode. Therefore the flow of current will be in the opposite direction, that is from cathode to anode. That is important here. In which direction there is a flow of charges, in the opposite direction the flow of current will be in its opposite direction. So in this here the electron is transferred, the flow of electron takes place from zinc, that is from anode to cathode. So the flow of charges will be in the opposite direction in this way. Now here, because of the charge separation here, the potential is developed. That potential here, the potential which is associated with the electrodes are called as electrode potential. What is electrode potential? The potential associated with each electrode is called as electrode potential. So here there is a electrode potential at anode side and at cathode side. So these are called as oxidation potential and reduction potential simultaneously. If the concentration of each species taking part in the electrode reaction is unity, like if the gases are used in this electrode reaction, then it should be of 1 atmosphere pressure, and the reaction is taking place at the temperature 298 Kelvin, and if the concentration is taken as 1 m, in that case what we call this type of electrode potential, that is called as standard electrode potential. Then it is called as standard electrode potential. So what is standard electrode potential? When the conditions are taken as standard, that is the concentration is taken as unity, that is 1 m. If it is a gas, it is taken as 1 atmospheric pressure at 298 Kelvin. Then the potential of each electrode is called as a standard electrode potential. So here standard electrode potential is represented by E naught. So E naught values are the standard electrode potential. For the case of hydrogen, that is standard electrode potential, E naught value for hydrogen electrode is 0 volt. So here each electrode have a specific E naught value because the values we are taking in the standard condition. So that is actually shown in a table that is given in the textbook. This is the table which showing the E naught values for the different electrode reactions that you can see here. These values for hydrogen, that is standard hydrogen electrode, it is 0 volt. This series is called as a electrochemical series. Here the E naught values are given here. You can see that hydrogen, the E naught value, that is as a standard condition, it is equal to 0 for the hydrogen electrode. Now you can see here there are negative values, you can see here, and there are positive values of E naught, that is the standard electrode potential values. So here this series we can see that here the increasing strength of oxidizing agent, that is in this direction. In this direction there is a increasing the strength of oxidizing agent. That means if the values are positive, or we can say that if there is a greater E naught values, that you can see here point, that is here 2.87, 1.81. So greater the value of E naught, we can say that they have a greater strength of oxidizing agent. That means that will be more, have a greater strength of oxidizing agent. And the values you can see here, from here to here, the values are actually decreasing, and that is increasing the strength of reducing agent. That means greater is the negative value, greater will be the strength of reducing agent. So these table will help to identify that which element will displaces which element. As we have learnt that in the displacement reaction, the more reactive element displaces the less reactive element. That is actually we can very easily explain through this chart, that is which can displaces the which metal in the salt solution. So the more details about the different type of cells and the importance of electrochemical series, that will be discussed in the next year, that is in the 12th standard. There is a chapter which is called as electrochemistry. So the details of these will be discussed in the chapter electrochemistry, that is the 12th standard chapter. So this is all about this video. Have a nice day.